So, page 18, all right? It's review from the stuff that we did yesterday, which is specifically finding the axis of symmetry and the vertex and the y-intercept from the standard form of a quadratic function without the use of a calculator, or Desmos, I should say specifically. All right. So, remember, for all of these, I always tell you to do what first? What's the one thing that I told you yesterday you always should do first, Owen?
A, B, and C.
Right, list your A, B, and C value. So what's my A value, guys? 3. And what's both my B and C value? 0. There's nothing there, so we call it 0. Now, the y-intercept is always the what value? The C value. So what's the y-intercept? 0, 0. Axis of symmetry is given by this formula, x equals negative b over 2a. So if I plug everything in, I have negative 0, which 0 can't be positive or negative, so it's just 0, over 2 times 3. So that's 0 over 6. Anything being divided into 0 is always what? 0. So how would I write my axis of symmetry? X equals 0. Don't forget that x equals. And remember, not only is that the axis of symmetry, that's the x value of the vertex. All right. So how do I find the y value of the vertex? Who remembers? Plug it back into the original equation. So I'm going to plug that 0 back in for this x up here. So if I do that, I got 3 times 0 squared. 0 squared is just 0, so that's 3 times 0, which is just what? 0. So my vertex is also at the origin. All right. So that was the first one. If we look at number 2. All right. I'm going to list A, B, and C first. So what is A, B, and C, Kyrie? Negative 1, 6, and negative 15. Good. So that being said, what's the y-intercept, Caden, with a C?
0 over negative 15.
0, negative 15. Good. All right. Axis of symmetry. Tell me how I plug it into my formula, Riley M.
Negative b over 2a.
All right, so what numbers am I putting in?
Negative 6 over 2 times negative 1.
Good. So that'll be negative 6 over negative 2. And what is that, Riley? Let me simplify that. Good. So x equals 3 is the axis of symmetry. That is also the x value of my vertex. So tell me how I plug the 3 back in to get my y value. Chris. So how do I plug it back in? What would it look like? So negative 3 all squared plus what? Good. Good. So remember, since the negative is originally in the function, we're only squaring the 3 and then applying the negative after. So 3 squared is 9, so we have negative 9 plus 6 times 3, which is what? 18 minus 15. So 18 minus 15 is 3. So Chris, what's negative 9 plus 3? Negative 6. So that is the y value of my vertex. All right. Number 3. So first off, A, B, and C. Let's go with Abby. What's A, B, and C?
240.
2, but the 4 is
-40.
-4, 0. Good. So what's the y-intercept? Ephraim. Good. All right. What is, or how do I put my values into the axis of symmetry formula, Ralph? So for negative b over 2a, what's that going to look like in the formula? So -4 over 2 times 2. Good. Negative times a negative is a positive, so I have 4 over 2 times 2, which is 4. So Ralph, what's the axis of symmetry? It's what? X equals 1. Good. It's also the x value of my vertex. So how do I plug it back in to get my y? Rajan. All right, so what will that look like? 2 times 1 squared times. Good. So 1 squared is 1, so 1 times 2 is 2. 1 times 4 is 4, and it's still negative. So Rajan, what's 2 minus 4? Not 2, but 2 minus 4. It's -2. So that would be the y value of the vertex. All right, last one of this type of problem. So A, B, and C, what are those values? Rayleigh. So good. Good. All right, so what is the y-intercept? Caden with a K. Good. All right, how would I set up my axis of symmetry formula, Ariely? Good. So that'd be -8 over -4. So what's my axis of symmetry, Ariely? Good. So x equals 2. So that's also the x value of my vertex. Then to find my y, how would I plug it back in, Addie? Squared. Don't forget the square. Good. 2 times 2 is 4. Times -2, that's -8. 8 times 2 is +16 plus 7. -8 plus 16 is +8 plus 7. So Addie, what is my y value of the vertex? Not 19. 8 plus 7. Yeah, you're good. 15. All right. Any questions on finding those 3 specific key features from the function without using Desmos? Now, again, this is just practice of can you put stuff in a formula to get these values, as well as can you identify the A, B, and C values? Because remember, when we get to unit 4, we're going to have to do that on a bigger scale with the quadratic formula. So even though, like, if this was on your test, I would just say put it in Desmos anyway. I still want you guys to at least get the practice of putting things into a formula. All right. So Number 5. First off, it's asking us if we have a max or min. Who remembers what tells me whether my vertex is going to be a max or min? Luke. Right, it's the positive or negative a value, so it's the coefficient in front of the x squared. If it's positive, it's a minimum. If it's negative, it's a maximum. So in this case, will I have a max or a min? A max. Now, the max or minimum value, remember that's the y value of the vertex. So I have to use the vertex formula to find it. So I got to do negative b over 2a first. So if I identify a, b, and c, that'd be -1, 4, -1. So negative b over 2a, that's -4 over 2 times -1. So that's -4 over -2, which is what? 2. So that's the x value of the vertex, but I need the y value. So I'm going to plug that 2 back in for x. So I have -2 squared plus 4 times 2 minus 1. What's 2 squared? 4 times negative, that's -4. Plus, what's 4 times 2? 8 minus 1. What's -4 plus 8? +4. And then minus 1. Be +3. So my minimum value is, or not minimum, my maximum value is 3. Now, from that, we can find our domain and range. All right. So by the way, I'm still going to list my vertex since I already found it. My vertex is at the point 2, 3. Now, domain. What did I say yesterday is always going to be the domain of any quadratic? Right, John? Negative infinity to positive infinity. What's another way I could state that? All real numbers. So I would take either negative infinity to positive infinity, or I would take just all real numbers. Either one of those is correct. They're synonymous. They're the same thing. Range. All right, so think about this carefully. Range is based off of our y value, specifically that of the vertex. It's also based around whether we have a max or a min. So we have a max. So does that mean that maximum value, so that 3, is that going to be my largest y value or my smallest y value? If it's the max, it's the largest. So if we were to write out the interval, all right, so I'd have something, comma, something. Would I put it to the left of the comma or the right of the comma? The right, because it's the largest. So I'd have a bracket here. Now, we know a max looks like this as a graph. So that means that lowest y value would be what? So what's the lowest y value? So our highest is 3. It's up here. What's the lowest? Negative infinity. Good. And you put a parenthesis. So you could write it that way, or I would also take y is less than or equal to 3. Because 3 is the biggest value, meaning all y values have to be less than it or equal to it. So guys, that's another thing. Domain and range you can also find as long as you know what the vertex is. And if you know whether it's a max or a min. Very, very easy to do. All right, last one. All right, so based off of the a value, is this going to be a max or a min? It's going to be a min because my a coefficient is just 1. It's positive. So we have a minimum. So now I need to find my minimum value. So I got to do negative b over 2a. A is 1, b is 2, c is 0. So if I plug it into the formula, I have -2 over 2 times 1. So that's -2 over 2. What's -2 divided by 2? -1. So that's the x value of my vertex. But I need the y value because that's what the minimum value is. So I got to plug it back into the equation. So I got -1 squared plus 2 times -1. What's -1 squared? not 2. Negative 1 squared. It's positive 1. 2 times negative 1 is negative 2. What's 1 minus 2? Negative 1. So that's the y value of my vertex. So that is also my minimum value. What's going to be the domain of this function? Negative infinity to positive infinity. That's always the domain of a quadratic, otherwise known as all real numbers. Now, the range is where you got to do a little thinking. So again, y value of the vertex is going to be in your range. So if we have a minimum, is that negative 1 going to be the lowest y value or the highest y value? The lowest. So in my interval, would it be to the left of the comma or the right of the comma? The left. So I put a negative 1 with a bracket. So what would be to the right of the comma? Positive infinity. Because it will look like a U. So it goes on forever. You can also rewrite that as y is greater than or equal to negative 1 because it's the smallest y value. Any questions on that stuff? How do you guys feel about that? Not too bad? All right, so today is going to be a lot of Desmos. So I need you guys to go ahead and take out your Chromebooks and get on to Desmos. All right, you're going to need it for today's lesson. And I'll enact the Go Guardian, so that should automatically open up Desmos for you. Also, have your packet open at page 20. So you need Desmos up, packet to page 20.
The tallest person in the class should not be the one that's in the front. I can't see.
I'll make sure to push the screen up. Just let me know if it's too low, okay? Yes. All right, does everyone have Desmos up? All right, so first thing I want to do, since you already got Desmos up, go ahead and input this top function on page 20 and find everything that's listed there. So I want the y-intercept, the axis of symmetry, the vertex. Tell me whether it's a max or a min, and then generate a table of 5 values and write that down. All right, so you can completely use Desmos for this. So you're typing it in to Desmos and then finding all of those key features very quickly. Now, if you get some decimals in your answers, don't be alarmed. That's why we're using decimals instead of the formulas. Mm-hmm. Oh, yeah. All right, you guys find everything? Give you guys one more minute. Huh? Hit the gear key and then hit the little table icon. All right. So if you graph that function in Desmos, this is what it should look like. Now, again, what I like about Desmos is that it already marks a bunch of the key features for you. So vertex, axis of symmetry, not the axis of symmetry, vertex, y-intercept, x-intercepts, marks all that stuff for you. So you just have to click on it. All right. So what did you get for the y-intercept? Here. Not here. We're not here. 3 in a row. Riley E. Jared. So what'd you get for the y-intercept? Good. So if you click on where it hits the y-axis, you get 0, -9. What'd you get for the vertex, Micah? So what'd you get for the vertex? Right, it's 0.6 and then -10.8. All right, so that's why I said if you see decimals, it's okay. So what'd you get for the axis of symmetry, Olivia? X equals 0.6. Good. All right. Is that going to be a max or a min, Kaylee? So is the vertex a max or a min? So is the vertex a maximum or a minimum? 0.6 -10.8. So does it look like it's the highest point or the lowest point? So it's a min. All right. All right. And then lastly, the table of values. All you got to do is hit that gear key hit the table icon, and then just copy down that entire table because that's 5 values right there. All right, any questions on how I got all that stuff from Desmos? All right. Now, solutions. What's another name for solutions? So what's another name for solutions? It's a key feature. Who remembers? I'll give you hints. The key feature that we haven't talked about yet. So not only is it called solutions, it's called roots. It's called zeros. What key feature am I talking about? It's x-intercepts. Good. So I'm talking about the x-intercepts. So we would write solutions as x equals the set if we have more than one. So we do the little squiggle. If I go to Desmos, I'm going to go up to the x-axis. It already has them nicely marked for us. I'm going to click here and here. Now, it looks like they're going to be irrational numbers, so I'm just going to round to the nearest hundredth. So the first one will be negative 0.87. The second one will be 2.07. So this would be negative 0.87 and then 2.07. Those are my two solutions or x-intercepts. Now, finally, f of x is equal to 5. So here's my question. Are we finding an x or y value? X. Because remember, f of x is the same thing as y equals 5. So who has a strategy for how we can use Desmos to find that? So who has an idea or a strategy of how we can find that? I'll give you a hint. I kind of already wrote out what you kind of need to put in Desmos. So if you put y equals 5 into Desmos, all right, on top of the graph that we already have there, what would I be looking for? So what would I be looking for? So once you put it into Desmos, you're going to look for the point of intersection, which is where it crosses the other graph. It should already automatically mark it for you. And you want the x value of that point. All right, so that's what I'm going to do. I'm going to type in my next box, y equals 5. Make sure you put the y equals. Now, there's two lines. If you look, it already marked both of them. So there's actually more than one x that works for this. So I'm going to list both. So I'm going to say, again, I'm going to round to the nearest hundredth. So negative 1.18. That's the x value of the first point. And 2.38. That's the x value of the second point. All right. So when y is 5, x would equal either negative 1. What did I say? 78? And then 2. Wait. Yeah, that's what I thought. 1.8 and then 3.8. And then 2.38. So that's how you can basically find any x value or y value from a graph. You just put it in. All right, you just type in whatever you're finding. So y equals 5, x equals 2, whatever. Find the point of intersection with the graph, and then use the value that you were not given as your answer. All right, so why did we go through this? Because today we're talking about projectile motion. All right, so projectile motion is more of an application of quadratic functions. All right. And to solve these word problems, it's actually completely Desmos. Now, does anyone know exactly what projectile motion is?
How fast somebody to be honest
Not necessarily. So you want to know what projectile motion is? There you have it. All right. It's literally if you throw something, it's talking about how far it goes up, and then when it hits the ground, how long it'll take. So it's always in terms of time and height. All right. You may see this with like rockets. This is definitely a physics thing, so that's where the speed and velocity comes in. But we don't really necessarily play around with that. We just more care about stuff like what is the height at a certain time, what is the maximum height, how long does it take for it to reach that maximum height, when does it hit the ground, and how far off the ground is it when it was launched. So let's look at this first problem and see if we can't figure it out. So all of these things that they're talking about are going to be some form of key feature that we just mentioned. So a ball is thrown straight up from the top of a 128 feet tall building. All right. So if we had a building, some dude threw a ball from the top of that building, and it'll go up, 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 and then hit the ground eventually. All right. And that building was 128 feet tall. The initial speed was 32 feet per second. The height of the ball of the function of time can be modeled as the function h of t is equal to negative 16t squared plus 32t plus 128. And the question is, how long will it take for the ball to hit the ground? So before we even graph this in Desmos, let's first figure out what we're trying to find. So let's think about this logically. Let's say that the y-axis is in line with the building. All right, so that's the y-axis. The x-axis would be at ground zero. So in other words, the ground itself. So if I want to know the time when the ball hits the ground, what do you think I'm going to find? So look at the picture. The ball hits the ground where? But where? On the x-intercept. So we're looking for the x-intercept. Now, we know quadratics typically have more than one x-intercept. They possibly have two. Which one do you think I would use? Yeah. Which one do you think I would use? So would I use the x-intercept on the left side or the right side? If you don't know yet, that's okay. We'll look into it. So we know we're finding x-intercepts. So let's go ahead and take the function and plug it in. So I'm going to replace t with x because Desmos won't graph it unless it's x. So I have negative 16x squared. I've definitely put 46. So negative 16x squared plus 32x. It was plus, right? Or was it minus? It's plus, okay. And then plus 128. Now, we're looking at the x-intercepts. So I'm going to zoom out just a little bit so that you guys can see what's going on. I'm actually going to change my screen to kind of look at it. So I want my x-axis to be, let's say from negative 50 to positive 50. All right, so now I got a little bit of a better idea of what this picture is going to look like. All right, now let's kind of analyze this picture here. I'm actually going to make the x-axis smaller. There we go. Now, if I'm looking at this picture, all right, what part of this picture do I really not need? All right, so what part of this picture would not look like the picture that I drew here? The negative side. So in other words, the y-axis, so I have the y-intercept highlighted, all right, but the y-axis, if it's to the left of the y-axis, we don't need it. Why do you think that is? Well, we start the y-intercept first off, but also, what does x represent in terms of the problem? So what does x stand for in terms of the problem? What does it represent? Not speed. Time. It represents time. Can we have negative time? No. All right, so we only care about the right side of the y-axis because that's where all the positive x values are. So my question was, which x-intercept, because there are two, all right, there's one here and one here. Which x-intercept would I use? The right one or the positive one. All right, so that would be what? 4. So it hits the ground right here at 4, 0. So how many seconds was that? So how long does it take for it to hit the ground? 4 seconds. That's all you have to do. It's easy peasy lemon squeezy. You just got to make sure you have the correct units. All right, let's try another one. So, a ball is thrown straight up from the top of a 288-foot tall building with the, yes, sir. Yes. With an initial speed of 48 feet per second. The height of the ball is modeled by this function. So, when will the ball reach a height of 320 feet? All right, so a little bit different. So this isn't necessarily a key feature, but it does take something that we did up at the top. So if we're talking about a height of 320 feet, am I talking about an x value on my graph or a y value on my graph? So x always represents time, so that means y represents, it's literally in the problem, guys. What does it say? Height. All right, so if I'm talking about height of 320 feet, that means I want y to equal 320. So we're going to do exactly what we did up here with the f of x is equal to 5. We're going to put it into Desmos and find the points of intersection and use those x values. So first, I need to graph that equation. So you really only need to manipulate the equation that we already got there. So we just got to change this 32 to a 48. And this 128 to 288, was it? Yeah, 288. Now you may got to zoom out just a little bit. Now, I then want it to be at y equals 320. So it's all the way up here, almost to the peak. So I'm going to zoom in just a little bit so we can see it. Now, we have two different x-intercepts. All right. Could only one of them be correct, or could both of them be correct? What do you think? Both. because they're both positive. So they could be both correct. But in terms of the problem, this 320, so 1 second, where is it? Is it before it starts falling, or is that still like when it's going up? It's still going up. What about 2 seconds? It's falling. All right. So it's coming back down to the ground. So if I read you a picture to kind of model what was going on, I had the 288 building. Someone threw that ball. Someone threw that ball. All right. Hit the ground at some point. And we wanted a line that represented 320 feet in the air. And it hit at 1 second and 2 seconds. So it hits 320 after 1 second when the ball is launched, and 2 seconds when the ball is falling. The reason that I want you guys to know the difference between the two is sometimes they'll ask you after how many seconds will it reach 320 feet and it's falling to earth, or after how long after the ball was launched did it hit 320 feet. Now, projectile motion is usually the main type that you'll see these key features, but you will also see them with kind of using it to model other things. And those same similarities also come in handy. You're still just using key features. It just may be a different scenario. All right. So this next problem is a completely different scenario. So the equation y equals x squared minus 12x plus 45 models the number of books y sold in a bookstore after X days after the award-winning author appeared at the autograph signing reception. So it asks, what was the first day that at least 100 copies of the book were sold? So if they're asking what was the first day, are we finding an X or Y value? X, because X represents the number of days. So we're finding an X value. And it says at least 100 copies. So as long as we sold 100 copies, we're fine. So that 100 copies is going to represent our what? So 100 books were sold. That's going to represent our what? X or Y? The Y. So we're going to do the same thing we just did with the previous. We're going to plug the function in, then type in Y equals 100, find the points of intersection. So go ahead and do that. Squared plus or minus -12. Yes, sir. Yeah. All right. So once you type it in, we notice that we have two. All right. We have two X intersect or points of intersection. So think about this logically. X represents the number of days. Which point of intersection is the only one that makes sense in terms of the problem? So which point of intersection makes sense in terms of the problem? So look at the X values. Think about what they mean in terms of the problem. What do you think, Rajon? Right, the 15.541 is the one that we want to use. Why? Why are we using that one specifically? Someone besides Rajon. Oh, and what do you think?
Because the other one is negative.
Right. And what is X representing? Time, but specifically what unit of time? Days. We can't have negative days. All right. So now it says at least 100 copies. So here's my question. Based off of where that 15 is, all right, we're clearly going to have to round. We're going to round to the nearest day. Now, would I have to round up or would I have to round down? Up, right, because it didn't hit 100 copies until halfway through the 15th day. All right, so 16 is actually what the answer would be. So the first day that at least 100 copies of the book was sold. Actually, I lied. It's actually the 15th day. Because since they sold it halfway through the 15th day, they reached 100 copies. It's still on the 15th day. Sorry. So after 15 days. So guys, when you're doing these word problems, find the key features isn't hard, but sometimes you do have to make the decision of which one to use. So that's when you have to think about logically within the problem. Obviously, if you're talking about time and you're looking for an x value, you do not need to be using a negative x value because it doesn't make sense for time to be negative. All right. Same thing with, say, it said you're hitting the ground. All right. And they want you to find a y value. You wouldn't be using a negative y value either because otherwise you'll be going to the center of the Earth's core. All right. It's asking when it hits the ground, not when it implodes in the ground. Write your name on board. So, just some features here, specifically with projectile motion. First off, this is generally what you'll see in Desmos. The only part of the graph that you should be caring about is to the right of that y-axis. All right, that first part that's on the negative side of the y-axis, so the negative x's, we don't need because it doesn't make sense in terms of the problem. So that means that negative 0 right here gets thrown out because you can't have negative time. Now, if you have the y-intercept, that tells you how high off the ground did the object start. So in other words, it's your initial height. So the initial height that you launched the object, the initial height of whatever building you threw it off of, the initial height of the platform, whatever. All right. Y-intercept always represents your initial height. Your vertex has two different features of it. So the x and y value. The x value represents when the object hits the max height. Your y value represents how high the object gets. So in other words, if you're looking at the vertex, the x value is the time, the y value is the actual max height. So the time it reaches the max height and the actual max height. All right. The positive 0. So the positive 0 or the positive x-intercept. That represents when does the object hit the ground It also represents how long is the object in the air. All right, because remember, as soon as it hits the ground, it's not in the air anymore. And of course, you may be asked questions like, how high is the object after some number of seconds? So how high is the object after a number of seconds? What you do is you plug in the given seconds into the graph's equation. Or in other words, you do x equals whatever the number is, find the point of intersection. So if I did that, that means I would have some vertical line. This would be the point of intersection. And my answer would be the y value of that point. Now, the opposite is true if it asks how many seconds to reach a height of some number. That's when you would do y equals that number, find the point of intersection, and use the x value. Now, note, you may get more than one, but you always need to use the positive version of that. So for example, if I drew that horizontal line, here's the point of intersection. Since this is the only positive one, that's my answer. But remember, sometimes you get more than one positive answer. So if you get more than one, you can list both. Or read the question carefully to see which one you would have to use. Any questions on those values? Now, something else you need to note. These two values right here are typically what is used here. Now, if you notice, there's always constants. So these constants are always my A values. So my B value is usually velocity or speed. That's for both of them. My C value is obviously the initial height because that's the y-intercept. Now, does anyone know, can anyone take a guess of what those two constants represent? I'll give you a hint. They're different units. They represent different units, feet and meters, of the same property. Does anyone take a guess of what it represents? So think physics. All right, you throw an object, it goes up, and then it falls back down. So what do you think that constant represents? What typically makes an object fall? Gravity. So those constants actually represent gravity. It's actually half of the normal constant for gravity. All right. So these two constants represent gravity. That's why they're always going to be the same numbers. You're always going to see either negative 16 or negative 4.9 if we're talking about projectile motion. The difference is the 16 is in feet, the 4.9 is in meters. That's the only difference. So the reason I'm telling you this is occasionally you may have to put it into the function. You may have to put the values into the function. So knowing what's what will tell you what to do. All right, occasionally. More often than not, you don't have to, but occasionally they may make you do that. So you just need to know what those, specifically what the B and the C values mean. All right, usually they'll tell you what the A value is going to be. Any questions? All right, last one we're going to do is this problem. So, a dud missile is fired straight into the air from a military installation. The missile's height is given by this formula, where t is in seconds and h of t is measured in feet. So, first things first. The first question asks, how high is the missile off the ground when it is fired? So, let me ask you this. What am I looking for? Like, what key feature do you think I'd be looking for in this case? Why what? So we're looking for a y value because it's asking you how high. But what specific y value? The y-intercept. Because it says when it is fired. All right? Fired, that's saying its initial height. That's when it goes out of the rocket launcher, the RPG, whatever. All right? So we're looking for the y-intercept. Now, do I even need to graph this to find the y-intercept? No. What can I use? The c value. All right. So, how high off the ground would it be? 100 what? Feet. Make sure you put those units. Now, let's check myself very quickly. So, I'm going to type in the function. So, negative 16x squared plus, what was next? 400x plus 100. May have to zoom out a little bit. Oops. All right. And there's the the y-intercept right here. And it's right at 100. So we are correct. All right. What is the missile's initial velocity? So this is not a key feature. This comes from the equation itself. So which value, A, B, or C, represents the initial velocity in the equation? B. So B represents the velocity. So we would say that the initial velocity was 400 feet per second. Remember, velocity is always in units per time. So it was launched at 400 feet per second. It then asks, how high is the missile after 4.5 seconds? So what do I need to do? So this is definitely going to Desmos, but what? Is 4.5 representing an X or Y value? It's an X. So I'm probably going to have to put in X equals 4.5 into Desmos and find the point of intersection. So if I do that, I'm going to write in X equals 4.5. Again, you might either have to scroll up or zoom out to see what's going on. Okay, I'm just going to straighten up my window some. All right, so this I want it to be at 20, negative 20, 20, 0.5000. All right. By the way, what I did was I just changed my screen just to see the graph better. To do that, you just hit the gear key and you can just put any X values and Y values that you want to change it to, just to make it easier to see. So I'm finding the point of intersection, which is right there. So how high is it after 4.5 seconds? So how high is it? 1,576 feet. That's the Y value of that point of intersection. So 1,576 feet. Now, it then says, at what time will the missile reach its maximum height? And then it asks, what is the maximum height? So what am I finding? Essentially, what key feature do I need to know what the max height is? What typically gives us a max, guys?
A vertex.
The vertex. So we're finding the vertex. Now, the time of the max height comes from what value of the vertex? The x. The max height comes from what? The y. So I'm going back to my graph. I'm going to click on the vertex. So how long does it take to hit the max height? 12.5 seconds. So 12.5 seconds. And what is the max height? 2,600. What? Feet. So after 12.5 seconds, it reaches its max height of 2,600 feet. Letter E asks, at what time will the missile land on the ground? So what am I looking for? So when does it hit the ground? What represents the ground on the graph? The x-axis. So I'm looking for the what? So the x-axis is where the ground is. What am I looking for? The x-intercept. Specifically, which one? The positive one. So I'm looking for the positive x-intercept. So I go back to my picture. Which one's the positive one? The left one or the right one? The right. So there's my x-intercept. I'm going to round that to the nearest hundredth. So I'm going to say after 25.25 seconds. So 25.25 seconds. All right, last one, then we're done. When will the missile be 2,500 feet above the ground? So if we're talking about feet above the ground, what am I talking about? An x or y value? A y. So I'm probably going to be putting in y equals 2,500 and finding the what? The points of intersection, yes. And remember, there may or may not be more than one. You just got to make sure you use the one that makes sense. So I'm going to type in y equals 2,500. So the points of intersection are here and here. Now, since they're both positive, we use both. All right, so it's at 2,500 feet at how many seconds? 10 and 15. So it's 250 feet above the ground at 10 seconds and 15 seconds. Any questions on projectile motion and how to find the features that's asking for? So again, that picture that we just did previously, that's a good reference for you guys to be looking at. And by the way, you'll have that same picture in your journal for that entry. All right. So use that to help you reference which key feature you're finding. All right. So your assignment for today, there's a new Delta math. All right. You guys got a solid like 10-ish minutes. Okay. And don't forget, all the Delta math are due for units 1 through 2A and 2B. So up to 2B. So from 1 to 2B. Those delta mass are due tonight by midnight.
Not the 3.
No, nothing on unit 3 is going on this term. All right, so you don't need to worry about the unit 3 delta mass, at least for what's going on this term, but you do need to worry about the units 1, 2A, and 2B delta mass. I will take them up until midnight tonight.